Now that we've introduced all of the formal ingredients of our model and we know how to represent graphically the firm's costs and we can represent graphically the consumer's preferences, it's time to introduce a notion of equilibrium so that we can make predictions about what will happen in this market. And we're going to work with a notion of competitive equilibrium. We will assume the market is competitive. Now, if one goes and reads the original paper by Rothschild and Stiglitz, there is a definition of equilibrium in there. What we're going to do is adapt the definition of equilibrium just to suit our purposes. So there's a definition in the original paper which essentially from which you can deduce all of the things I'm going to say. We're just going to take those parts as our definition of an equilibrium just to keep our exposition as simple as possible. So what do we expect to happen in an equilibrium? Well, because it's a competitive equilibrium, the first thing we would expect is that firms will earn zero expected profit. And indeed, we will assume more than this. We will assume that both contracts earn zero expected profit. So firms are not earning zero expected profit by making money off one contract and losing money off the other contract. A competitive equilibrium is a set of contracts, CH and CL, where both of these necessarily earn zero expected profit. So this reflects the idea of competition. Any contracts that were profitable, another firm has competed those profits away, offering the consumers better and better contracts until they reach a point where firms are earning zero expected profit. The second condition for a competitive equilibrium for us will be that the high-risk consumers choose contract CH and the low-risk consumers choose a contract CL. Now, these contracts may be the same, CH equal to CL, which is what we call a pooling equilibrium. But if they are different, then we are assuming that high-risk consumers choose contract CH and low-risk consumers choose contract CL. Now, this assumption, to interpret this, will depend very much on our informational assumptions. So if we assume perfect information, so the firms are able to identify without any cost the different types of consumers, and consumers know their own types, then there is a costless way of separating the high-risk consumers, and we can simply assume that this assumption holds. If, however, we have a situation of asymmetric information where the high-risk consumers know their type, the low-risk consumers know their type, but firms cannot tell the difference between the two types, well, that is where a very important idea is going to come in. This idea of screening consumers and designing the contracts in such a way that this condition is guaranteed. It is perhaps this idea which is the most important in this lecture and possibly in the whole course. It's called incentive compatibility, and we will come to it later in the lecture. The third condition for a competitive equilibrium set of contracts is that, subject to the above conditions, both contracts earn zero expected profit and high-risk consumers choose contract CH and low-risk consumers choose contract CL. There should be no other contracts that dominate these contracts CH and CL. What do I mean by this? Well, an alternative contract would dominate these contracts CH and CL if the relevant type preferred such a contract, and also that it could be sold by a firm without losing money, so if it made non-negative profit. So if we had a contract, for instance, that high-risk types preferred to contract CH, and also that such a contract could be sold and make a positive expected profit, then that would violate the condition of CH belonging to the equilibrium set of contracts. An implication of this condition is that subject to conditions 1 and 2, so of all the zero expected profit that each types of contract that each types are offered, they must be offered the contracts that they prefer the most. Otherwise, there would be another contract that dominates the contract they're being offered. So you can interpret condition 3 in two ways. The first saying that, well, of all of the zero expected profit contracts these consumers are offered, they're offered their most preferred. And the second is that if there is another contract that could make profit, then these consumers must think it is worse than what they are being offered. Now that we have a notion of what a competitive equilibrium set of contracts is, let's study what these contracts must satisfy under different informational assumptions. So our first assumption as a baseline case will be the case of perfect information, being the case where all consumers know their own type, and also that firms are able to distinguish between the different types of consumers and are not prevented in any way, in any legal way, by offering different contracts to different types of consumers. Let's go on paper and derive the competitive equilibrium of this market under these conditions. Okay, so now let's derive the competitive equilibrium contracts under the assumption that there is perfect information. So both types of consumers know their own types, and firms are able to perfectly identify any consumer's type. Now, the way we'll interpret this assumption is to say that the firm is able to say, well, high-risk customers must buy the contract CH, and low-risk customers must buy the contract CL. I mean, that's the only contract that will be offered to them. Now, remember, these are two-dimensional objects. So CH, the contract CH is has CHG in the good state and CHB in the bad state. And the contract CL similarly has a good state level and a bad state level. The reason I mention this now is because when you look at the problem of trying to characterize these contracts, there are 1, 2, 3, 4 things that we need to know. So ideally, we're going to be able to come up with 4 equations. Okay, if we're looking for 4 things, we need 4 equations really. So what are the equations? Well, 2 of them we know straight away. Okay, so high-risk types are only allowed to buy CH, and in equilibrium, it must earn 0 expected profit. Okay, so straight away we know that E, if I take the expected value of CH using the probability PH, this has to equal the expected value of the endowment. Okay, so that could be equation 1. And equation 2, similarly, the low-risk contract, if I take its expected value under the assumption that only low-risk types are buying it, then that should give this equation, which said the expected cost to the firm is equal to the expected revenue. So it's a 0 expected profit condition. What does this mean graphically? Well, it means, now I've prepared our kind of contract state contingent consumption space diagram here. We already know how to plot ISO cost lines on this. So I'll draw a steep ISO cost line here and label that as the 0 profit line for low risk types and a flatter line here. And I'll label this as the 0 profit line selling to high risk types. Okay. And you can remember that this low risk line, 0 profit line, has slope 1 minus PL over PL. So it's an ISO cost with that slope, and it passes through the endowment, which is what makes it a 0 profit line rather than just any old ISO cost. Now, so our first 2 equations say, well, CH has to be somewhere along this line, okay? CH has to be somewhere along this line, and CL has to be somewhere along this line, okay? So that's what we know so far, 2 equations, and we've pinned it down to saying CH is on this line and CL is on this line. What else can we say? Well, we know that the following is also true, that these contracts are the most preferred from the consumer's perspective of these zero profit contracts. So we could write a problem and say, well, they will be the contract CI will solve the problem, maximize the expected utility, let's say for type I equals H or L. The expected utility of this contract, just subject to CI is the solution. So I'm choosing a contract, I'm choosing C to maximize the expected utility of this contract subject to the condition it must earn zero profit. Okay, so the expected cost of the contract is equal to the expected revenue, the expected value of the endowment. Okay, so solving this problem will essentially give me the contracts. What does this mean graphically? Well, we know that an indifference curves kind of come underneath here. We're saying each consumer is on, the contract is on this line somewhere on the highest indifference curve possible. Okay, on the highest indifference curve possible. And we should be used to this by now by saying, well, if I'm looking for solving a problem like this, or trying to get onto the highest indifference curve, the first order condition will always be slope of this equals slope of that, okay? So a tangency condition, let's call it a tangency. So the first order condition set will say, well, the indifference curve will be tangent to the zero profit line. So let's analyze the first order condition, this tangency condition, more formally. So we've already shown that the slope of an ISO cost, so the derivative of CB with respect to CG, assuming or with the condition that change in expected value equals 0, so we're looking at an ISO cost, this is equal to minus 1 minus PI over PI, where I is the type of the consumer, high risk, low risk, or unknown. We've also shown that the slope of an indifference curve is almost the same, so the negative of this odds ratio, and then there's an extra term, this ratio of marginal utilities, the marginal utility of CG over the marginal utility of CB. If we take these, then a tangency is going to say that these are equal to each other. And so our first order condition, this tangency condition can be expressed as follows. The negative of the odds ratio is equal to the same thing, the negative of this odds ratio, multiplied by this ratio of marginal utilities. And of course, this means that the ratio of marginal utilities term has to equal 1. And so at the equilibrium contract, the marginal utility of consumption in the good state has to equal the marginal utility of consumption in the bad state. Now, remember that we've assumed utility is strictly concave, and so marginal utility is always changing as consumption increases, marginal utility is decreasing. It's always positive, but it's always decreasing as we increase the level of consumption. And so the only way this equation can hold is if CIG, consumption in the good state in the equilibrium contract for type I, is equal to CIB, consumption in the bad state for the equilibrium contract for type I, where I is H or L or X, high risk, low risk, or the unknown type. Going back to our diagram, what we've seen here is that this tangency occurs on the 45-degree line. Okay, so I could just make a note. I could just draw this tangency here. and say that this is an indifference curve IL, and at this point here there's another tangency, and that this indifference curve is IH. Okay? And then here, where this tangency occurs, is contract CH, equilibrium contract CH, and here is equilibrium contract CL. So this is the picture characterizing the competitive equilibrium under perfect information. The firms earn zero profits. The consumers, obviously, if we look at their starting indifference curve, it's down here for low risk. They get this great increase in utility, moving from their endowment to something that has the same value, expected value, but is risk-free. So for them, that's much better. This is the function of an insurance market for them to pass the risk from consumers who are risk averse to the firms who are risk neutral, and allow the consumers to enjoy the increased utility they receive from that full insurance. So let's go over the basic characterization of competitive equilibrium, a competitive equilibrium set of contracts when there is perfect information in this simple insurance market. Well, we showed that two conditions must be satisfied. First of all, both contracts must earn zero expected profit. So graphically, the contract for high-risk types is somewhere along this red line, and the contract for low-risk types is somewhere along the light blue line. And the second condition, which was derived by the fact that consumers are offered their most preferred contract, and consumers are strictly risk-averse, and so the most preferred contract is the risk-free contract along this line. So the contracts also lie on the 45-degree line. The contracts offer the same level of consumption in both states. So this occurs where indifference curves are tangent to these zero profit lines, and the net result, or the overall result, is that the consumers are offered actuarially fair, so this means zero expected profit. They are actuarially fair contracts that offer full insurance. Every consumer receives full insurance at a fair price. That's the basic result of competitive equilibrium, the basic characterization of a competitive equilibrium when there is perfect information. Now that we've derived the competitive equilibrium set of contracts under the assumption of perfect information, let's consider the case of void information. Now, by void information, we mean that consumers do not know their own type, and firms don't know firms cannot identify the different types of consumers either. So there is effectively one type of consumer, the consumer that does not know their own type, which we denoted by type X. So the analysis is very similar, so I'll just go through this on the slides. We know that an equilibrium is characterized by the condition that the contract must lie on the zero profit line, and for the case of type X, the consumers that don't know their type, the zero profit line will be this purple line denoted pi subscript X equals 0 that passes through the endowment. So along this line, the firm makes zero expected profit selling contracts to consumers in exchange for their endowments where consumers do not know their own type. And of all of these contracts, we know that the consumers must be offered the most preferred contract, and this occurs at a tangency point where the indifference curves have slope minus 1 minus px over px. And so the contract, the most preferred, this tangency condition occurs on the 45-degree line, where all consumers are offered full insurance. They receive the same level of consumption in both states, which is what it means to be fully insured, and they are offered this contract at the actuarially fair price. So that is the characterization of competitive equilibrium, a single contract, or CH is equal to CL. So we just have one contract, which we label CX. It must earn zero expected profit, and it must be the most preferred of such contracts. So it's a full insurance contract. In Lecture 5, when we study the value of information, we will actually come back and study the case of void information versus perfect information in a little more detail. So it's worth going over this again just to make sure it is fully understood at this point.